A second method for finding the greatest common divisor or least common multiple comes from using the prime factorizations. I've got the theorems listed, but I'm going to talk through the theorems as I do a couple of these examples, show you how this works. To find the greatest common factor, what you're doing is you're going to look at, let me write this here. You're going to look at the prime factors that they have in common, and then you're going to use the smaller of the exponents. So for instance, we have I equals 3 squared times 7 to the first times 11 to the first times 13 to the third. J in this case is 3 to the first times 5 to the second times 13 to the second. So they both have a 3 as a prime factor and they both have a 13. So we're going to use the 3 and the 13 for the greatest common factor, and you want the smaller of the two exponents. So we have a 3 to the second and a 3 to the first. We're going to use the 3 to the first. Then we have a 13 to the third power and a 13 squared. We're going to use the 13 squared. So our greatest common factor is 3 times 13 squared. That's 3 times 169, or 507. When you're finding the least common multiple, you're in a sense doing the opposite. For the least common multiple, you're including everything. Nothing is left out, so you're going to include all of the factors. Even if that factor only occurs in one of the two numbers, you're going to include it. When there's a factor that is included in both numbers, you're going to use the higher exponent. So the least common multiple is much more inclusive. It wants everything. So starting with the 3's, I'm going to go with the 3 to the second. I'm using that higher exponent. The second number, J, has 5 squared, so I need to include that. And I'm going from smallest to largest prime factor here just to give it some sense of order, in case anybody's wondering. Then I has 7 to the first power, so we'll include that. I also has 11 to the first power, so we need to include that. And then we have 13 cubed and 13 squared. We're going to use the higher exponent, the 13 cubed. To find the least common multiple, we're going to need to multiply all of these together. I'm going to go ahead and just give you the answer. You probably want a calculator, unless you are really, really good at your mental arithmetic. Probably want a calculator for these, because the least common multiple here is 38,063,025. Also, I don't know if it's picking up on the recording, but one of my cats is going a little crazy this morning. So if you hear some strange little noises in the background, it is Frankie. Okay, let's look at this next pair of numbers. Same process. And at this point, you might want to pause the video, try it on your own, and then come check your answers. But we have M and N here. We're going to find the greatest common factor first. So in this case, we're looking, what do they share? What do they have in common? Well, they both have 2's. When I'm dealing with the greatest common factor or greatest common divisor, I'm taking the smaller exponent, so it's going to be the 2 squared. M has a 7, N does not. N has the 3 and a 5, which M does not as prime factors. But they both have 13, and they both have 13 squared, so that's what we're going to use. So here we have 2 squared, or 4 times 13 squared, which is 169. If you multiply 4 times 169, you get 676. That's our greatest common factor. For the least common multiple, again, we're going to include absolutely everything. When they share a factor, you want to use the higher exponent. So we have 2 to the fourth, 3 to the first, 5 to the second, 7 to the second, and then 13 to the second. So again, in this case, probably want a calculator, though it's not going to be quite as large as the first LCM. In this case, we get 9,937,200. And then one last time here, we're given P and Q. So we're going to start with the greatest common factor. They both have 2's. They both have 2 to the third power. So we're going to include that 2 to the third. P has a 5, a 19, and a 29. Q does not. Q has the 3, 7, 11, which P does not. So our greatest common factor is just 2 to the third power, or 8. The LCM, on the other hand, this one is a little crazier. So again, I'm going to write these in order from smallest prime factor to largest. So you'll see me going back and forth between the two, between P and Q. So we end up with 2 to the third power times 3 to the first power times 5 to the first power times 7 squared times 11 squared times 19 squared times 29 to the first power. And when you multiply this out, you're going to get a very large number. It's 7,448,484,120. So that's a second way that you can find your greatest common factor or greatest common divisor and your least common multiple. You can use the prime factorizations.